No other aspect of sailing offshore has more impact on the boat and crew than the weather. While we can't control the weather, the more we can understand about it and the forecast that lies ahead, the better our chances of a safe and successful passage. For the Storm Trysail Foundation, I'm Gary Jobson. Noted safety and seamanship expert Ralph Naranjo, and author of The Art of Seamanship, spent time with us talking about how we can better use weather information to our advantage. So before you go sailing, what do you look at concerning the weather in advance?
Probably start with the most simple equation, and that's check the VHF radio. Listen to whether there's a watch or a warning, whether there's thunderstorms in the picture. Don't let it discourage you, but at least be aware of what they're forecasting.
How about other sources? National Weather Service, Weather Channel, .coms?
At home, the Weather Channel is a good primer. I like National Weather Service information. The Ocean Prediction Center gives you a wide range of what's happening offshore. It also gives you a forecast as well as an analysis. The analysis is what's happening now. The forecast is what's going to happen down the road.
So once you get on the boat and you have this forecast that's either in your mind or maybe you've jotted a few notes down or printed something out, how do you monitor that as the voyage goes on?
First thing, it's part of a mindset. What you're looking at is what's going to happen down the road. That helps to drive tactical decisions on the race course. Or if you're long distance cruising in a short-handed context, it gives you a better idea of what to expect. So what I do is I try to take what I've had for initial forecast and information and update it. I update it twice a day. During a evening roundup of navigation efforts, checking that forecast and seeing what changes have taken place are important. You can do it with a single sideband or with a satellite weather equipment, but what you're getting is the real-world National Weather Service analysis that's in play at the given time.
Do you spend much time just kind of observing the weather when you're out sailing?
I do. And my barometer is my best friend. The barometer is I'm not concerned about the actual number in millibars or inches. I'm concerned with the trend. In other words, what's the change over a given amount of time?
What would be an alarming change?
If you're seeing a few millibars an hour change, you're about to have the paint blown off the mast. It's not just a change in a downward direction, but heavy air comes from the upward spring of the barometer also. The high pressure system gales off the California coast were notorious. What they mean is that you have a big cold air mass coming in and it's changing pressure in a very short period of time.
So you would call this developing weather awareness?
Absolutely. That combined with the cloud cover. You're looking at what kind of a deck you have, whether you're looking at cirrus clouds that are indicating a warm front approach, or you're looking at broken cumulus, fractocumulus, that means the cold front's gone through and you're moving into a high pressure system.
So much of sailing seems to me simple common sense. At what point are you on a boat and say, the weather's bad now or it's getting worse, we should go in? When do you make that determination to just say, it's better if we head in?
The option to head in is always one to play and look at carefully. If you have a chance to get into safe shelter, you do so. I like to do it well ahead of time. If I'm leaving from land, I take the Weather Channel to heart. It gives you what's happening to the west of us. In other words, 80% of our weather happened in California a few days before. It's coming across the country. Yes, we have coastal lows and we have developing patterns that come out of the Gulf, but much of the weather moves from west to east.
How much time should somebody spend learning how to read a weather map?
I think it's an effort well worth doing. To understand the Norwegian model and how low and high pressure systems are separated by cold fronts and warm fronts, what a trough of low pressure is, those are the fundamentals that need to be in place because those are the graphic signs that tell you what's going to happen.
Tell me a little bit what the Beaufort scale is and what it does.
The Brits have a wonderful idea of what Beaufort was all about, and he talked about sea condition as well as wind velocities. Put them together so that you know what you're going to expect with size of wave with a given amount of wind. And that's really important for an ocean sailor.
How concerned should we be with lightning?
Depends on where you are. If you live in Florida or off the mid-Atlantic or in some parts of the Caribbean, lightning's a big deal. Lightning is less of a big deal if the vessel is properly bonded and grounded. The main thing from my perspective is you know when you have thunderstorm likelihood, meaning time of year, and then you pay real heed to a serious amount of lightning. It usually goes hand in hand with high developed cumulonimbus clouds, highly developed, and an atmosphere that's unstable, which is an indicator of potential strong microburst, downbursts, and other cataclysmic events.
How do you know that your boat is properly grounded?
Well, you follow ABYC standards, which spell out what should be tied together. And when I say tied together, I mean wired together with conductors attaching through hull fittings, stanchions, the keel bolts, and the mast, and tying the metallic parts of the boat together and attaching them to a zinc at some point along the underbody of the vessel.
One of the phenomena that we see in New England, specifically Maine, or most often Maine, is fog. How should sailors handle it in foggy conditions?
It needs to be taken really seriously because along with fog, we have a highly trafficked coastline. And it's not just shipping traffic, it's smaller vessels, it's recreation as well as small commercial craft. The nearshore waters have the tugs and barges plying them. The deeper waters, more merchant traffic. So in an era of GPS, you feel fairly confident of knowing where you are, but you don't know what's around you. AIS is a help, but there's nothing better than a visual good deck watch going on when you can see it, but when visibility goes away, radar is king.
Describe AIS to me.
Automatic Information System is a radio finding device that tells you with a assurance what vessels are nearby that also have an AIS transceiver on board. And that's the crux of the matter. They have to have the radio equipment and they have to be transmitting at the time for you to know if they're there.
You talk in your book about thunderstorm seamanship. What can you do to avoid being in a thunderstorm?
Well, if it's a single cell thunderstorm, you can normally see the cloud top. And much of the time in summer months, we can see 30,000 foot development or higher. That's only one storm in itself. It may be moving at 20 knots or more, but it'll have a directional consistency. And the idea, if you're not racing, sailing away from that single cell storm is a good thing. However, probably 50% of the time it won't be a single cell thunderstorm. It'll be a cluster of storms, often referred to as a line squall, that come through in a cluster. Those you're not going to avoid.
So you're out in the water, far from land, thunderstorms are coming. What precautions should you take? What's your prudent seamanship?
If it's looking and sounding, and when I say sounding, I mean turn on an AM radio receiver and listen to how much static there is. Pretty good explanation of how severe that thunderstorm will be. If it's going to be a severe frontal passage with a bunch of thunderstorms, things like crew have PFDs on. You want to have a PFD on during a thunderstorm passage. You also want to follow a prudent rule if you're cruising. Less sail area is more. In fact, many times in a really bad thunderstorm passage, a short-handed crew will take down a mainsail. Face that thunderstorm with just a scrap of jib up. When it's blowing 50 knots, you'll be happy not to have coped with the main. If you're racing, that's not in the cards. So the main thing you want to do is have enough room from the lee shore to be able to run off during the worst of this without putting yourself aground. Usually one tack or the other is going to allow you to do that. But the idea of in a heartbeat, you need to be able to cope with sail area. That's part of good thunderstorm management.
What point do you put up your storm trysail or storm jib?
Storm trysail has as much to do with sea conditions and heavy wind. It's a situation where water's breaking over the boat, where, as a good friend of mine who lost his rig approaching South Africa said to me, he was doing great until a wave broke in the middle of the mainsail. So the idea with a storm try is it's set not on the boom, but well above the boom, so that seas breaking across the deck are going to clear the foot of the sail. It's set on a separate track. You're going to use the same halyard that you use with the mainsail. That's a precarious point. When you transfer the halyard from the mainsail to the storm jib, to the storm trysail, it's a point where if you let it go, you're in a world of hurt, because most boats have one main halyard, period. The storm trysail is, in a nutshell, 40 knots of wind or higher. If you're short-handed, you might move that down to 35 knots, where you use the heavy weather jib in a storm try. What it does for the short-handed person, it means that when it kicks up to 50 knots, you're not going to have to set the storm trysail because it's already up.
Unlocking the mystery of the 500 millibar chart. Tell me what that is. What do you mean by that?
The atmosphere is three-dimensional. We think about weather on the surface. The 500 millibar chart depicts the weather halfway up in the atmosphere. It's just about through half of the height of the air mass that we have. What the 500 millibar tells us is where the lows and highs on the surface are going. It actually steers the lows and highs on the surface. Sometimes it'll also tell us how severe a gale on the surface is going to be. A clear picture of a ridge or a trough in the 500 millibar zone, which is about 15,000 feet above the surface, will tell us where that low is going to track, and is it going to strengthen or is it going to fizzle. Pretty important to a sailor.
Well, something that we all fear are hurricanes or tropical depressions, and they seem to come through every few years. We get a big one. Which it wouldn't do if they hear about a forecast with a hurricane.
Yeah, hurricanes and tropical storms, if you're on the East Coast, this part of the world, mid-latitudes, my rule of thumb is if it's south of you, be real cautious. Because our understanding of severity of tropical storms and hurricanes is pretty good. Directional forecasting has been not quite as refined. Hurricane Sandy was a good case in point. The models all conflicted right up until a couple of days out. And the idea of New York taking the brunt of it and Long Island getting hammered hard was not in the picture until maybe a day and a half or so before the storm hit. So if the storm's south of you, be real concerned. The next thing is there's a big difference between a tropical storm and a hurricane severity of sea-wise. When you have a fast-moving Category 1 or 2 hurricane, it can push a lot of sea ahead of it. Many people think that if they sail north or northeast and get into higher latitudes, they'll be in good shape. Hurricanes and tropical storms do an odd thing. When they disassociate and become extratropical, they actually get larger in diameter. So it's much like a wider scatter on a shotgun blast. Your chances of encountering some serious weather is significant. It may not pack the 100-knot punch, but 60 or 70 knots of wind with a mature seaway ahead of it is a real difficult thing to cope with.
So what are your favorite weather sources? We kind of touched on in the beginning, but you talk about VHF radio, good quick overview, any alerts there, National Weather Service. But there's some more weather services available to people. What are some of the ones that you like?
I like a lot of the grid file information. When I'm not big boat sailing, I'm windsurfing, so I'm very interested in the micro forecast for a local area. But one thing I've found out is grid files look great graphically, but often they're directionally as well as intensity a bit off. And when it's supposed to be 15 knots and it's blowing 28, or when it's supposed to be 20 and it's blowing 7, even if it's from the right direction, you really want a little better information on intensity. So before I head to sea, I'll read a little bit about what Weather Underground is saying about weather systems that are in the area. I'll look at NOAA's information. And for those who have it in the budget to go after a concierge weather service, that's not a bad thing to do. My recommendation is make sure, like Rick Shima, you deal with a meteorologist who has had a good track record in formal education as well as the oceanographic side of things. So Rick and Ken Campbell and a number of others are top tier sources for guidance if it's in the budget to do that type thing.
So you can contract people individually. If you're going to do a passage, it doesn't hurt to get a little forecast over the period of time where you're going to be.
Especially if you're in a new area where there's climatology involved. In other words, here in the U.S., we have an odd thing where we're trying to get out of town in November. November is the hurricane season is theoretically out of the way, but what we see is the winter gales are right on the doorstep. So what we end up having to do is find that weather window. In other words, a stable weather pattern where we're not going to see too many vigorous frontal passages, at least until we're past the north wall of the Gulf Stream and we've got some easting already in the bag.
So some early indication of weather changes coming.
Mm-hmm.
I can prompt you through the list, or maybe you can just...
Well, we can, main thing to me is a rapidly dropping barometer. But I also like to keep an eye on cloud cover. The mare's tails, those very high altitude cirrus clouds that are coming out of the west, they're showing where the next weather system is coming from, and usually it's a couple of days before the warm front reaches us. You'll feel the humidity increase. The sun gets a halo around it. It starts to get gray and fuzzy, and you enter, things warm up. This is not usually bad weather. It's usually overcast, a little bit of rain. But on odd occasions, you can get a warm front that packs a big punch. Will pack gale force gusts in the thunderstorm, so on and so forth. Unusual, but it does happen. Then the cold front is about to arrive, and on the edge of the cold front, you'll see a big shift from the southwest to the northwest. Thunderstorms, pretty brutal weather, short-lived, and then the surprise is the sunshine comes out, the northwesterly is there, but it may not be a kind northwesterly. It may be one that packs 30 to 40 knots of wind. Usually late fall, early spring, those things happen.
How about an occulted front?
Yeah, the occluded front ends up a combination of warm and cold interface, cold front interface. And what you're going to have that you need to be aware of is you can have secondary weather systems develop on it, much like a stalled front where the cold front catches up to the warm front. And what you're going to see there is new low pressure systems form, and that's referred to as a triple point. So on the stall fronts you start to spin up a secondary low, that low can often be stronger and more of a danger than the original low was. And that's a typical November scenario or March. One of the key things weather-wise that's important from my perspective is the out-of-phase nature between wave trains and wind. Wind is shifting at a literally slower rate than where the wave train indicates. In other words, waves move away from a low-pressure system at several hundred miles an hour, while that weather system is moving along at maybe 20 or 30 knots over the sea speed. So what you're going to get is you're going to get waves that were based on the original wind direction, but the low or tropical storm, tropical hurricane is moving slower to that location. What that means is that the wind and wave faces are not perpendicular to each other. The point here and the tactical thing is one tack is going to put you running on a reach, but with the seas almost astern. That's not a bad position to be on. The more dangerous one is where you're literally running dead downwind, but the wind is closer on the beam. And that is not a pleasant spot to be on, and it's a much more hazardous spot to be. So during the worst of a storm, the concept of being on the jibe that favors this seas astern, wind more in a broad reach position. Makes a world of sense.
Tell me a little bit about the experience of flying colors with a storm that was almost pre-season.
Flying colors was really a tragic event. This was a well-fit out, sound, seafaring little harbor 54 that went to sea several times, professional skipper. She came back from the Caribbean at the right time, early May, came back up, and while they were approaching the Cape Hatteras area, a storm had developed, and that storm intensified very rapidly. It was an unusual shoulder season tropical storm that began as a normal nor'easter, what we call an extratropical storm. The weather system began to form up about May 5th. And by May 6th, things were still fairly calm around Cape Hatteras. Seas were fairly light, 3 or 4 feet, and within 24 hours, the seas were up over 30 feet. The wind was blowing 65 knots sustained. 4 vessels got into real trouble, and 4 vessels abandoned, the crew abandoned ship, or 3 of them abandoned ship, were rescued by Coast Guard assets. Flying colors set off its distress signal, but no sign of the vessel was ever found. She disappeared about at the fringing edge of the Gulf Stream, the north wall of the Gulf Stream. The effect of the weather certainly was intensified by the stream, and goodness knows what the conditions were like at the time. But several EPIRB signals were transmitted. The beacon the beacon signals lasted for about 3 hours, or it may have been less than that. But quite a tragic episode. All were lost aboard.
Horrible tragedy.
Absolutely.
And frightening everybody left behind. The boat just disappeared, never to be seen or heard of again.
Quite a search went on after it. The Coast Guard mounted both an air and a sea search. The Navy participated. And the only thing we can say, it's a very large and deep ocean out there.
Yeah, and if they were on the edge of the Gulf Stream, they could have been carried hundreds of miles and then finally sank, and you don't know.
With no sign of any wreckage or debris found, and the vessel apparently had a functional EPIRB, but it may have gone down with the vessel.